Hello students, welcome to the IMS Gate Academy. How are you all? Okay, so hoping that everything is good and whatever preparation you are doing are at its peak. So yeah, I'm back again with a new topic, and as you know that we had started the most expected concept for the GATE 24 and the upcoming GATES exam. This is not only for the GATE exam, like it is a topic or the series that we are doing for the PAN India exams, you can say, like those who are belongs to the technical. Okay, all right. So yeah, see, you know that I had already completed the electrical machines of the most expected concept, and those who have not watched, please once this lecture is going to be over, you can watch all those session. Definitely you will going to have a great experience. And now coming back to this session, for the measurement, we had completed the 2 lectures, and we have seen quite important topic, as well as along with we have completed the most important question for the respective topic. Okay, all right. So coming back to this session, which we are going to have the topic as a 2 wattmeter method. Again, it is one of the most important topic. You can expect at least one question at least twice or thrice a year. So the importance of the particular topic is very high. Okay, so definitely you can expect at least 1 to 2 questions from this particular topic. And again, it is belongs to both the stream EE and IN. All right. So guys, one request, please do like the session, and also please share the session with your friends, so that they may also going to come to join our session in a live manner, so that we are going to have a well interactive session, isn't it? And also if you have not yet subscribed to our YouTube channel, please do subscribe, so that you will going to have a great experience. And also please do not forget to press the bell icon. Okay, so yeah, let us start. Whatever query you are having while the session, or whatever general query you are having, please do shoot in the chat box. I will going to answer all the queries. Okay, so coming back to the topic, that is 2 wattmeter method. So as we all aware that the 2 wattmeter method are basically used to measure the power in the electrical circuit. So basically this belongs to the chapter measurement of power. So yeah, measurement of power is basically what you are going to have a single phase power or a 3-phase power, isn't it? So for the single phase power, we require 1 wattmeter to measure the single phase power. In the same way, you are having the 3-phase power, I mean to say 3-phase AC power. So in the 3-phase AC power, we will going to have 2 method. First one, 1 wattmeter method, and the another one is the 3 wattmeter method. So if the source and the load are balanced, then we can measure the 3-phase power by using single phase wattmeter. What do you mean by this? Not a single phase, basically single wattmeter method. What I mean by that? The meaning is that if the load is balanced and the source is balanced, then we can find the power across a single phase, and if you are going to multiply those power 3 times, then you are going to have the 3-phase power. But for that, what is the constraint? The load and source has to be balanced. And what is the another alternative? That we can use the 3 wattmeter method. But those things are you can say cumbersome, isn't it? As I told you, to measure the 3-phase power, we require balanced load and a balanced source, which is not always true. Similarly, to measure the 3-phase power by using the balanced load or source or unbalanced load or source, then we can use a 3 wattmeter method. But again, by using 3 wattmeter, it is a cost effective, isn't it? So which is not at all acceptable. So what is alternative for that? Alternative is 2 wattmeter method. So there was a scientist called Blondel. He given one idea is that if you are having a 3-phase line and a 1 neutral wire, then we can have the 3 wattmeter method. Or else by using the 3-phase line itself, we can measure the 3-phase power. But for that, we require the 2 wattmeter. So got the point? So if you are having a neutral, like if the neutral is already given, then we can have a single wattmeter or a 3 wattmeter. We can easily measure a 3-phase power. Or else, if you are having if you are not provided with the neutral, or if the neutral is absent, then we can have the 1 wire to be considered as to be acting as a neutral wire to measure the 3-phase power. Okay, so let us start with the topic, that is the measurement of three-phase power by using the 2 wattmeter method. Now if you see here, you are having the three-phase line. Phase A, which I named it as 1 as per my convenience, you can say. You are again going to have the another phase, which is phase B. Let me call it as 2. Phase C, which is the 3, which is the third line here. Now if you see here, this the third line or the phase C line, I have considered as a neutral line, because whatever current is coming here, it has to return it, isn't it? The line has to return. The current should have the return path. So return path is provided by this third line. Okay, so here I have assumed that the source is balanced. So what do you mean by balanced source? Means for phase A, phase B and phase C, magnitude are same, as well as the phase displacement between the respective phases are 120 degree. Okay, so what I mean to say, suppose phase A voltage is Vm sin omega t, then for phase B its magnitude has to be same with respect to as that of Va, and similarly it has to be phase displayed by an angle of 120 degree. Similarly Vc magnitude will be same, and again it will phase displaced by again 120 degree. Like minus 240 means it is in clockwise direction. For anti-clockwise the angle will be positive. So this may also be written as Vm sin omega t plus 240, sorry, plus 120. Okay, minus 240 in clockwise direction, which is equal to plus 120 in anti-clockwise direction. Similarly, we can also write this as Vm sin omega t plus 240. Great. So yeah, this sort of concept we should require. Now here we have taken the impedance. So here this impedance is denoted as Z1. Ignore this resistance symbol. Okay, ignore this resistance symbol. Please assume that you are having the impedance over here. Okay, Z1. So let me take this as Z2. Let me take this as Z3. As we are measuring what? AC power. Na? So the AC power is basically what? In terms of impedance, RLC. So combination of the 3 component or any of the 2 or a single one, like a single parameter. Done. Okay, all right. So a 3-phase 2 wattmeter measures the current and the voltage from any of the 2 supply lines of the 3-phase corresponding to the 3rd supply line of the 3-phase. Next, a 3-phase 2 wattmeter is said to be at a balanced load condition if the current in every phase lag at an angle of phi with phase voltage. So these 2 things we should be keep in mind. And what is that? By using the 3-phase, like if you are having the 3-phase, then for every respective phases, phase A, where the voltage V1 is the phase voltage for the phase A, and Z1 is what? Is the impedance. So everywhere impedance is same. Similarly, for every impedance, whatever current that is entering to the respective phases, it is lagging by an angle of phi, which is written over here. Okay, do not get confused. Once we will going to draw the phasor diagram, you will come to know. All right. So these are your phase voltages which I have written here: V1, V2 and V3. Okay. So if you see carefully, this is your 1 phase, this is your 2nd phase, and this is your 3rd phase. Done? Okay. All right. So see, for this kind of thing, one prerequisite is required, and what is that? Your 3-phase connection can be done in 2 manners. The first one, either the source or the load, the source and the load can be connected in a star, or it can be connected in a delta. So whatever result we are going to get, are equally valid for the delta as well as for the star. Suppose if I am deriving the formula for the star connection, then whatever formula we are deriving, those are also valid for the delta type of connection. Okay. All right. So in the prerequisite, first we need to see the relation between voltages. Okay. let me take V1, V2, V3, which is equal to VPH. So these are phase voltages. These are phase voltages. Now let me remind you again. Here we need to assume that your source and load are balanced. So here magnitude of the respective voltages are same and the phase displacement between one another is 120 degree. Okay, all right. So now let me take V12, V23 and V31. These are what? Your line voltages. Okay, these are line voltages. Okay, what do you mean by this? The voltage from 1 to 2 is the line voltage because you are measuring the voltage from line to line, isn't it? From line 1 to this point, these are the phase voltage. And what about line to line? The voltage from line to line is what? Your line voltages. So this I have taken as VL. Similarly, this will be your VL. Similarly, this will be your VL. Whereas this voltage is VPH, VPH and VPH. Done? Okay. And your line voltage VL, this is equal to your √3 times of phase voltages. In the star connection, your line voltage is √3 times of phase voltage. In the same manner, I1, so let me inbox this is important result. In the same manner, your phase current, which is I1, I2, I3, this is equal to IPH. So this is your phase current. So the current which is entering into the phase I1, I2 and I3. Now let me take the line current. So if you see carefully, what current which is coming from the line? It is the same current. That is why in the star connection there is no difference between the line and phase current. So I1, I2 equal to I3, which is IL, which is equal to IPH. Okay, so this is the line current. Okay, so this point is very important. In the star connection, there is no difference between the line and the phase current, whereas in the voltages there is a factor of √3 in the phase when you are going to have the line voltage. Okay, so let me inbox this as well. Okay, any doubt till this point? Please do let me know. Okay, since I have told you that we will going to consider a impedance or a load as a lagging type of load, because most of the load or the practical load is what? Lagging type of load. So if you see carefully here in this diagram, for the respective phases, if you see what is the voltage V1, what is the current entering I1, and Z1 is what? Impedance. So if you see, the I1 will going to lag the voltage V1 by an angle of phi. Okay, just we have used the network KVL. Apply the KVL, you will see that your line current or the phase current will lag the voltage V1 by an angle of phi, where phi is what? Impedance angle of the load, or which is same as the power factor angle of the load. Okay, so let me write here. Let the load be lagging load and which gives the phase difference between phase voltages and phase current as phi. So here your I1 current which is equal to magnitude of I1 in the polar form lagged by an angle of minus phi. So this is what magnitude of I1? This is V1 divided by Z1 का magnitude at an angle of phi. So since V1 is equal to V2 is equal to V3, so only Z1 is equal to Z2 equal to Z3. Therefore, I2 which is equal to magnitude of Vt Z2 at an angle minus phi, because all are equal. Similarly, I3 which is equal to magnitude of V3 divided by Z3 at an angle of minus phi. Done? Okay. Now let us have the phasor diagram. Like here we will going to derive the equations. We'll going to derive the formula for the wattmeter 1, which I named is that P1, and this is wattmeter P2. Okay. Now see, to measure the power, to measure the AC power, what we require, my friend? So let me write here, to measure the AC power, what we require? To measure AC power, okay. What we require? We know the formula P, which is equal to voltage into current into cos of angle between V and I. So this V and I is what? Phase voltage and phase current, and the angle difference between those two. So if you see P1 here, this line, just a second. Okay, see this line. Okay, all right. Just a second. Let me change the pen over here. Okay, see, this is your okay. So this is your M, this is your L, and this is your C, and this node is your V. Now, if you see the C to V is what? This is your potential coil, which is going to measure the voltage. So this is your potential coil. Similarly, M to L, this is another coil which is going to measure your current, which is current coil. See, this is connected in series with the current, therefore it is measuring the current, and similarly this is your voltage. So this voltage is in parallel with this C and somewhere, yeah, okay, this is incorrect, somewhere between C and V. So therefore this coil, see this PC is what? Potential coil, which measure the potential across the here, potential across this line 1 to line 3. See the connection, see the connection. So it is potential coil is connected between line 1 to line 3, whereas your current coil is connected in line 1. So my dear friend, this P1 is what? It measures the voltage from 1 to 3, current I1 and cos of angle between V13 and I1. Done? Now similarly, please do let me know for P2, where is the potential coil? Potential coil is here. And where is the current coil? Current coil is here. So this is potential coil. Okay. So potential coil is connected between which lines? Line 2 to line 3, which is acting as a neutral line. And similarly, your current coil is connected where? In the line 2. So this will going to give you the current, and this will going to give you the voltage. So for P2 wattmeter, it will be V23 I2 and cos of angle between V23 and I2. So this we need to measure. Now look at here. Okay. Now look at here. Let me take this as phase A, let me take this as face A, face B, because face B will lag the angle of will lag the face A by 120 degree. So this angle is 120 degree. Similarly, face C will lag the face B by an angle of 120 degree. So this is again 120 degree. So this angle is what? 120 degree, because the total angle is 360, isn't it? Now we know that face A okay. So face A current, which is I1 current, will lag by an angle of phi. So this is I1. Okay. So this is your V1, this is your V2, and this is your V3. Okay. All right. So this phase angle is what? This phase angle is, sorry. Okay. So this phase angle is what? Okay. So this phase angle is what? Your phi. Please do let me know whether this color is visible or not. Okay. So this phase angle is phi. Now in the same way, for the respective phases, it will going to be lag. Okay. So this is your I2, this is your I3, and this phase is what? Phi. Similarly, this phase is what? Phi. As I told you, the respective phase current will going to lag the respective phase voltages. So V1, V2, V3 is all are what? Respective phase voltages. Now, but my dear friend, my task is to calculate this V13, I1 and angle between those two. So V13, what is V13 here? V13 is V1 minus V3. Similarly, what is V23? V23 is V2 minus V3. So where is V1? V1 is here, and where is V3? V3 is here. So, but we require minus V3. So minus V3 is exactly opposite to that. So let me change the color here. Okay. So this is minus V3. Now how to get V13? By using the parallelogram theorem. So this is your V1, this is minus V3. So if you take, just a second, let me change the color. Which color should I take? Okay, let me take green color. Okay. So this is your V13. How I get? Okay. By adding V1 and V13. Sorry, by adding V1 and minus V3. That is what we had written here, na? ठीक है? Now, one more thing. Let me change the color. Okay. So see, this angle from this point to this point, this angle is what? This is 60 degree. This total is 120. It will act as an angle bisector. So the angle here is 60 degree. So this angle is what? Again 60 degree, because total is 120. And this V13 will act as a angle bisector for V1 and minus V3. So this angle from this point to this point is your 30 degree. Similarly, this point to this point, this is again 30 degree. But my dear friend, I supposed to calculate the phase angle between V13 and I1. So let me see where is I1. I1 is here. I1 is here. This is your I1. And where is V13? V13 is here. Sorry. V13 is here. So I mean to say this angle. Okay, I mean to say this angle. ये कितना एंगल हुआ? This angle is what? I hope this is visible to you. थोड़ा small दिख रहा होगा, but try to manage it. So this angle. So this angle is, this total is 30. This is 5. So this angle is 30 minus 5. Let me write here. 30 minus 5. Done. So if I talk about P1 wattmeter 1 reading, which is equal to V13 I1 cos of angle between V13 and I1. Okay. So V13 is what? Line voltage, as I told you. And I1 is what? Phase current, which is equal to line current in star connection. So this is your IL. Cos of this we got 30 minus 5. Done. Now for P2, which is V23 I2 cos of angle between V23 and I2. Let us find this angle. Okay. So V2 is here, V3 is here. So minus V3 is opposite to that, but we require V23, which is V2 minus V3. So minus V3 already we have. So take the resultant of it. So it will be here. Okay, so let me change the color. So this is V23. Okay. So means vector sum. V2 and here minus V3. Okay. But angle between V23 and I2. So ये कितना angle हो गया? This angle will be what? Okay. So this angle is what? Again, this is your 30 degree. Again, this angle is 30 degree. So total angle between V23 and I2 will be what? 30 plus 5. 30 plus 5. So if you look at here, this V23 is the line voltage, which is VL. I2 is phase current, which is equal to line current. And cos of angle between those two is 30 plus 5. So please remember this two formula. This two formula is very, very important. Like if you remember this two formula, you can solve any question from this topic. So let me inbox this as well. So first this one and the another one is this formula. Okay, all right. So yeah, we have got the individual power. We have got the individual power, but how we will going to measure the total power? So how we going to measure the total power? So the total power is going to be measured by the combination of these two individual meter reading. What I mean to say, add these two, we will going to get the three phase power. See how? The first one, let me change the color. Okay, so the first one, three phase active or real power. So this is equal to P, let me write, which is equal to P1 plus P2. Let us add the both. What we are going to get? We are going to get VL IL cos of 30 minus phi plus VL IL cos of 30 plus phi. Done. So yeah, when you simplify this, take VL IL common, we'll get cos 30 minus phi plus cos 30 plus phi. So this is cos A minus cos B, isn't it? And this is cos A plus cos of A plus B. Cos of A minus B plus cos of A plus B means like this. Cos of 30 minus phi plus cos of 30 plus phi. So this is cos of A minus B plus cos of A plus B, which is equal to 2 cos A cos B. So 2 cos, or let me write VL IL 2 times of cos 30, this is A and this is B, and cos phi. So cos 30 is root 3 by 2, 2 will be cancelled out. So we will left with root 3 VL IL cos phi, which is the three-phase power formula. So how we will going to get to know the three-phase real power? Suppose if individual power reading is given to you, just add those two values, you will get the three-phase power. Done. Now let us go back to the second reading, which is the three-phase reactive power. Three-phase reactive power. So in this case, we will have to subtract the power. Like see, let me take Q dash. Why I am writing Q dash? You will come to know once we simplify P1 minus P2. So when you subtract these two reading, we will get VL IL sin phi, which is not the actual three-phase power. The three-phase means the reactive power. The three-phase reactive power is what? Root 3 times of VL IL sin phi. So here root 3 term is missing. So to get the total reactive power, we will have to multiply by root 3 to Q dash. So I hope you come to know that why I have written here Q dash. So basically this is equal to root 3 times of VL IL sin phi. Okay. So the next value that we can get, is the power factor angle phi. Power factor angle phi. How to calculate this? Let me write it. Power factor angle, which is phi. Okay. So let us divide the reactive power and real power, so that we'll get what? Tan phi. This is tan phi. Tan phi is what? Reactive power divided by real power. So reactive power is what? Root 3 times of Q dash is what? P1 minus P2. P1 minus P2 divided by real power, which is P1 plus P2. So from here we'll get phi, which is equal to tan inverse root 3 times of P1 minus P2 whole divided by P1 plus P2. This formula is very important. This formula. Okay, and the last one is the fourth one, which is power factor. Okay, so power factor means cos phi. So since we have calculated the phi, can't we able to get the cos phi? So cos phi is tan inverse root 3 times of P1 minus P2 whole divided by P1 plus P2. Again, this formula is very, very important. So anyway, like if you are able to remember this formula, you can easily get the cos phi value. So there is no point to remember this formula, but please remember this one because it is very, very important. Most of the time you will going to use this formula, phi wala. Okay, and now a precaution thing. What is that? Here most of the time a student used to miss this root 3. Okay, please remember, while applying this formula we need to multiply root 3, because when you subtract these two, you will not going to get the root 3 factor. So to get the 3 phase power, we will have to multiply by root 3. Okay, so that is why you are having root 3 here. And one more point that we need to remember here is that this P1 is what? VLIL. This is line voltage and line current. Similarly, this is your line voltage and line current. We usually have to remember like our habit to remember the formula for the single phase, which is VLIL, VPH, IPH, sin phi or cos phi. But like for the 3 phase power, we usually have to remember the factor root 3 or 3 like that. So please do not think in that manner. Here for P1 and P2, these are the reading of the individual wattmeter, and here you are going to have the line voltage and the line current and cos 30 minus phi and cos 30 plus phi. Got the point? Any doubt? Any doubt? Okay. And this all formula I had already written, so try to remember this all formula. Now let me write the important points. First one. Okay, important points. First one. If the load is lagging, then leading, not lagging. For the lagging we had already derived. For leading, then P1 will be VL IL cos of 30 plus phi, 30 plus phi, and P2 will be VL IL cos of 30 minus phi. So 30 is what? This is degree, na? That 30 is degree. Okay, so what I mean to say that whatever formula that you have derived for the lagging, just swap those two. That will become the reading for the leading type of load. Leading type of load means RC type of load. Okay, anyway, you can easily remember, like there is a shortcut for that. Since we have derived the formula by considering the lagging, so for leading the angle will be opposite to that ना. मान लो lagging के लिए आपने angle लिया है 30 degree, then for leading it will become minus 30. So what I mean to say, here replace phi with minus phi for the leading, then it will become 30 plus phi, and this will become 30 minus phi. Okay, so in this way you can remember, this is a shortcut. All right. And second one, in P1 and P2, the voltages are line voltage. Done. All right. Now come to the, I think it is written, yeah? Yeah, okay, sorry. It is already written over here. So yeah, see, important point is, with 2 wattmeter, we can measure 5 quantity, which is real, reactive, power factor angle, and apparent power. What is apparent power? It is the magnitude of real power and the reactive power. Suppose your S is P plus JQ. This is in complex power. This is known as complex power. Then what is apparent? Take the magnitude. Then this is known as apparent power. Okay, and this is your complex power. So I hope you have got the difference. If the power is written in the complex manner like P plus JQ, then it will be complex power, and if you take the magnitude of it, then it will be come as a apparent power. So the reading or the rating which is mentioned on the nameplate of the transformer, like we have seen na, 11 kV by 132 kV, 100 MVA. So that 100 MVA is what? Apparent power. Okay? So from now onward, I hope this will come to your mind, that whenever this is given, complex power, when the magnitude is given, apparent power. Next, if the load is delta connection, then also the formula for P1 and P2 will remain same, very important. Because most of the students think that, sir, we have derived the formula for the lagging, then how we will going to get the formula for the, for the star connection, then how we will going to get the formula for the delta. There is no difference between the formulas, whether the connection is star or delta. The formula will be same. And also, if the load is lagging, the formula will be same for both type of connection, and for the leading, the formula will be same for both type of connection. Connection means star or delta, and for the leading, I had already explained you. Okay. Now this is your summary. Like if you remember the comment or a relation with respect to the power factor angle or the power factor, then we can directly solve the question. There is no need to use your the pen and paper to solve the question with respect to this topic. If you remember the comment for the respective phase angle, then within a 5 second, even within a 2 second, we can be able to give our answer. Okay, now see, these are some standard power factor angle, serial number 1, like 1, 2, 3 and 4. For the respective power factor angle, phi 0 degree, 30 degree, 60 degree and 90 degree. What is power factor for that? Cos 0 degree is 1, cos 30 degree is root 3 by 2, which is 0.866, cos 60 degree is half, which is 0.5, and cos 90 is what? 0. Done. Then P1, which is equal to VLIL cos 30 minus phi. Substitute phi as 0 degree. What we are going to get? Cos 30 root 3 by 2. Similarly here. So the two reading, how we will going to give, how we will going to get the total power? Add those two, we'll get root 3 VLIL, which is the what? 3-phase real power. So both wattmeter will give the equal reading. So in the question, it may directly going to give you that if the power, suppose if the two meter reads the same value, then what will be the power factor or power factor angle? So if you are able to remember this one, then we can directly come to know that power factor angle will be 0 degree or power factor will be 1. In the same way, if the power factor angle is 30 degree, then P1 will be VLIL and P2 will be VLIL by 2. So 1 wattmeter will read half of the another. Okay, half of the another. If the power factor angle is 60 degree, then one will read root 3 times of VLIL and another will read 0. Cos 30 plus 60, cos 90 is 0. So if 1 wattmeter reading is 0, then for sure I will say that power factor angle will be 60 degree or cos phi is 0.5. Got the point? And similarly for phi equal to 90 degree, 1 wattmeter will read equal and opposite of another. So right here 90 degree, cos 30 minus 90 is what? Cos of minus 60. Cos of minus 60 is cos 60. So cos 60 is what? Half. So VLIL by 2. Similarly here cos 30 plus 90. Cos 90 plus theta. Cos 90 plus theta is what? Minus sin theta. So here minus sin 30. Minus sin 30. Okay? So minus sin 30 is minus half. So if you see here minus VLIL by 2. So if it is says that in the question, if 1 wattmeter reading are equal and opposite, then power factor angle will be 90 degree. If they are equal but not opposite, then power factor angle is 0 degree. Got the point? And one more thing, that the key point and the important point, if power factor angle is greater than 60 degree, if power factor angle is greater than 60 degree, then 1 wattmeter will read negative value. Why? Because here if this is greater than 60 na, then here reading will be here, this value will be more than 90. This will be more than 90, and anything more than 90 will give you negative value for the cos. इसलिए वहाँ बोला गया है, if the power factor angle is greater than 60 degree, then 1 wattmeter will read negative value. And in order to get the positive value, interchange the pressure coil connections. Okay, so this is all about your the theory portion. Now let us understand all the concept through our gate problem. Okay. See, this is the first question. When the measuring power of a three-phase balanced load by 2 wattmeter method, the reading are 100 watt and 250 watt. The power factor of the load is. So always remember that your P1 will be greater than P2, because in the P1 you are having 30 minus 5, means cos 30 minus 5, and in P2 you are having cos 30 plus 5. So cos 30 minus 5 is always greater than cos 30 plus 5. So therefore P1 reading will be greater than P2 reading. So whenever the higher value will be given to you, then consider those reading will be consider that reading will be as a P1. ठीक है, समझ में आया मैंने क्या बोला? Always P1 will be greater than P2. So P1 will be taken as a higher reading, which is 250 watt. Similarly for P2 it will become 100 watt, I guess. It is given as 100 watt. Now the power factor of the load is, so I need to calculate cos phi. Okay, so what is phi, my friend? Tan inverse root 3 P1 minus P2 upon P1 plus P2. So tan inverse root 3 times of, so this is 250 minus 100 whole divided by 250 plus 100. So let us see what we are getting. Tan inverse, this will be root 3 into 250 minus 100 is 150 divided by 350. So we are getting tan inverse 3 by 7. So 3 root 3 by 7. Okay. So we have got the phi, that is the power factor angle. So similarly for cos phi, this will be equal to cos phi is tan inverse 3 root 3 divided by 7. So when we solve this, we will going to get the cos phi as 0.8. As 0.8. Just a second. 0.8. Any doubt in this question? Is it clear? Any doubt in this question? Now let us see one more question that was asked in GATE 2022 in IN stream for 1 marks. In the balanced 3-phase circuit shown, C naught equal to 8.2 microfarad and the line to line RMS voltage is 440 volt at 50 hertz. The reading of the wattmeter is, so this is your wattmeter and the impedance is your capacitor, purely capacitor. Then what is the reading of the wattmeter? Now most of the student has given the answer as 0 watt. Why? Because capacitor will only accept the reactive power. Capacitor will always accept the reactive power. So it means that active power will be 0. So on the basis of that, most of the student has given the wrong answer, which is 0 watt. Here they are asking the reading W1 na, W1. Okay. So what is that readings? So let me change the color. Always write the reading, like the voltage reading and the and the current reading, but by seeing the connection of the wattmeter. Okay, so here in place of 1, 2, 3 they have taken R, Y, B. Okay, so wattmeter reading W1, this will be equal to what? Voltage across pressure coil, current through current coil, and cos of angle between VPC and ICC. Okay, so VPC is connected between which to which line? R to Y. See, R to Y. So this is V R Y, and your current coil is connected in R line. So I R. So we need to find cos of angle between V R Y and I R. Now in the question, if you see carefully, your line to line voltage is given. So V R Y is equal to 440 volt, and frequency is 50 hertz. Any more value is given? Yeah, capacitor value, which is 8.2 microfarad. Okay, so my task is to calculate VRY and IR. So IR is what? Is the current of the phase. So let us calculate IR. IR will be what? This will be equal to, this is the phase current. So VR, phase voltage, divided by impedance, which is कहाँ गया? XC, which is XC. Done. So this VR is what? Phase voltage, and XC is what? Capacitive reactance, which is equal to 1 upon 2 pi F C naught. Okay, so substitute here, will get 2 pi F C naught. 1 second, this will be J, because this is capacitive reactance, na, 1 upon this value. Okay, so this will be J 2 pi F C naught into VR. Let us substitute the value. 2 pi, F is frequency 50 hertz, C naught is given in the question as 8.2 microfarad, so 10 to the power minus 6, and VR is what? Phase voltage. And how to get the phase voltage from the line? By dividing it by √3. हम जानते हैं ना, VL is what? √3 times of V phase. So VL is VRY and √3 times of VR. So this is 440, divide it by √3, will get VR. So substitute here, it will be 440 by √3. So what value we are having? Just a second, let me see. Okay, anyway, let it be like this. Okay, let it be like this. So this can be written as, see here, this can be written as magnitude of IR at an angle of, this is 90 degree. So what do you mean by this? Your IC lead, not IC, IR lead VR by 90 degree. And we also know that your capacitor current will always lead the capacitor voltage by 90 degree, which is what we are getting. IR is what? Capacitor voltage, and VR is what? Phase voltage, which is the capacitor voltage. That is what we have got. And this value is magnitude of IR. ठीक है, कोई doubt? Any doubt? But my task is to calculate W1. See, so we require VRY, IR and cos of angle between those two. So for this kind of problem, always draw the phasor diagram. For such kind of problem, always draw the phasor diagram. So let me take VR here. VY this is VB. So this is VR, VY and VB, and all the angle is what? 120 degree. This is 120, this is 120, this is 120. Okay, so VRY. So this is VR minus VY. VR minus VY. So we are having VR here. So minus VY means opposite to VY. So take the vector sum of these two. So this will be equal to VRY. This is VRY. Okay. One more thing. What is the angle from this to this point? This is minus VY. So this angle is your 30 degree, and similarly this angle is your 30 degree. That we know. क्योंकि ये टोटल कितना है? This is 180. This is 180. तो ये कितना हो गया? It will be 60 degree, isn't it? It will be 60 degree. So ये एंगल कितना हो गया? Total 120 है. So this will be 60, and this will act as an angle bisection. Angle bisection means angle will going to divide it into two equal half. So 30 and 30. Okay, let me rub this. Okay, all right. So this IR is leading the VR. Here VR I have taken as a reference. IR will lead VR by an angle of 90 degree. So where is VR? VR is here. So IR is what? 90 degree leading means anti-clockwise. So it will be here. This is your IR. So let me change the color just a second. So this angle is 90 degree. Okay, this angle is 90 degree. So the angle between VRY and IR, angle between VRY and IR. So where is VRY? VRY is here, okay, and IR is here. So कितना एंगल होगा जल्दी से बताएं? From this point to this. Okay, see, this is 30 degree, and from IR to VR is 90 degree. So subtract 30 from 90. What we are going to get? We are going to get this angle. Which is 60 degree. Clear hai? This is 60 degree. Done? Okay. So my dear friend, let me change the color. So W1, which is equal to VRY, which is 440. Let me check, which is 440 line voltage. IR is magnitude. This is magnitude, na? This is magnitude. So IR is 2 pi into 50, 2 pi into 50 into C naught, which is 8.2 microfarad into 10 to the power minus 6 into 440 by root 3, 440 by root 3, and cos of angle between those two parameter. तो कितना हमने find किया है? What value we have found? 60 degree. So when you solve this, we will going to get the answer as 143.97. 143 sorry 143.97 watt. So the answer that we need to be feed over here is 143.97, which is the correct answer for this question. Okay, any doubt till this point? Any doubt till this point? Okay, so I hope you have enjoyed the session and you have liked the session. So whatever thing I have discussed, please go through once again. Once the session is going to be over, definitely you will going to able to solve all the question from this particular topic. Okay, so guys, please do like the session, because I have given my 100%, and also I know that you have also liked the session, isn't it? So please do like the session, and also please share the session with your friends so that they also going to get the benefit from this particular session. And also do subscribe our YouTube channel, because we are coming up with a new initiative in the month of November and December and January, so on and so forth. And also please do not forget to press the bell icon, which is very important, because I want you to be the first one to get the notified for our upcoming sessions. Okay, and one more thing, please do join our Telegram group. Link is already given in the description box. So from whatever group you are having, from EE, EC, IN, Civil, Mechanical, and so on and so forth. So for the respective thing, you are going to find the link in the description box. Okay, so let me end the session, and we will going to meet once again on today is Tuesday now. So on Thursday we will going to meet with yet another session from the measurement. So bye bye, and take a very good care of your health.